Good day, everyone, and welcome to the SIMULIA seminar series for the 2023 release. Today's focus is electromagnetics. Why electromagnetics is important? Well, in today's world where digitalization, communication, and electrification are critical industry drivers for sustainable innovation, electronics and electromechanical product design require very precise solver capability, modeling tools, as well as material representation. CST Studio Suite and Opera 2023 release help to address these challenges by introducing a wide range of new enhancement and improvement to increase the versatility and the performance in modeling, meshing, and solver technologies. In addition to the electromagnetics engineer role, we are able to offer you a full cloud experience from modeling to computing. After a brief overview on the electromagnetics portfolio, we will concentrate on the following highlights. So we will see the enhancement for antenna and microwave component design. We will then have a look at how we smooth the communication and detection system analysis. We'll then focus on assessment for electromagnetic compatibility, and then we'll have a look on our new enhancement for low frequency application, in particular for electromechanical device design. At the end, I will introduce you to the 3D Experience Cloud, which helps you to remove the barrier to access the high-performance computing for the simulation, but even how to access CST Studio Suite via a web browser. Let's start with an overview on today's portfolio for electromagnetics. Well, SIMULIA Electromagnetics portfolio is most comprehensive suite for high frequency and low frequency electromagnetic simulation. So the flagship product are definitely CST Studio Suite for the high frequency part and Opera for the low frequency part. But in addition, CST Studio Suite provide a set of tools for antenna and filter design, antenna MAGUS, Filter Designer 3D, FAST, and Spark. And last but not the least, a user can access dedicated modules for all electronics application, like integrated circuit, package, printed circuit board, and of course, cable. Bear in mind that CST Studio Suite and Opera, they share token and credit license with all SIMULIA products, from Abacus to PowerFlow. And as you can see, they are available for cloud computing as well. The portfolio is available as a desktop version, but even as on 3D Experience as well. With all physics analysts, this is a role that you can buy on the platform on 3D Experience Cloud, on the 3D Experience. You can then connect your CST Studio Suite on the platform. But if you want to have a full cloud experience, electromagnetics engineer is your role. And this role lets you access CST Studio Suite technologies and on desktop version. And since 2023, so since this release, you will be able to access this via a web browser. Could be Chrome's or anything else. We will talk about this a bit more at the end of the presentation. Well, in addition, thanks to the 3D Experience platform, we are able to develop new applications which streamline industry workflows, like, for example, antenna placement. And antenna placement is one role available exclusively on the platform, which helps designer in placing antenna for optimum electromagnetics performance and to validate the location of antennas early in the design process. But let's spend a few words on what is the 3D experience. Well, as you know, SIMULIA wants to reveal the world we live in. to reach this goal, we can leverage the 3D Experience platform to connect data, to connect processes, and of course, to connect people. If we consider how we connect process, well, you can, thanks to the platform, you can centralize your work by creating dashboard to track and monitor your works and sharing them with your all members. You can have your own, you can collaborate socially. So you can create your own community on the platform, could be public or private. You can exchange information. In addition, you can use the platform to store, organize, and share stuff. So not only with internal, but even with external stakeholder. And you have an intelligence ways to a way to search, navigate, and discover by using tagging and so on. You can even then visualize on 3D your structures as a tree, but even in 3D. And the last but not the least, you can efficiently collaborate by managing the life cycle of an object, which represent your IP, your intellectual properties. You can use the 3D markup to maybe submit, prioritize, and assign issue, which may require some quick resolution. But let's focus how we can now leverage, for example, the 3D experience to connect the data for simulation. Well, we have been working for simulation. So we have been working to enable the connection between CST Studio Suite and the platform in order to keep track of any changes during the design cycle. In this way, so you can run simulation on a virtual twin, and you can do it in an early stage of your design process. As I mentioned, so we have been working to in the past to make the 3D CAD data from the platform available in Studio Suite. We did it for the 3D wire harness, but even for PCB, so you can upload printed circuit board on the platform and then simulate it through CST Studio Suite, as well as even for electronic circuit behavioral model. This year, we have been focused on adding material properties, accessing, for example, finite element mesh, but even having the possibility to use abstraction shape. Let's have a look at a simple, a nice example showing how we can select the data that we want to import. So this is a basic antenna substrated grounds that have some holes, for example, for the assembly. For simulation, the holes are not necessary, but you cannot modify your geometry. So you may be as a simulation engineer, so you don't have the right to do that. For this reason, so we create a so-called abstraction shape. An abstraction shape is linked to the original CAD data, but you can add on the top of the original CAD data some changing, for example, to simplify the part. So on the platform, you can access the different materials. So you can, for example, assign to the FR4, to the substrate, and so on. You can assign to the antenna. Could be maybe a perfect electric conductor, or maybe a lossy conductor. So as you can see, this can be done on in a shareable way. And once this is saved, so you or a colleague of yours so can access that by loading the 3D shape into CST Studio Suite. And as you can see here, you can select which parts you want to import and which part you don't want to download from the platform. So you are connected to the platform, you are accessing the data now, so the material, the geometry is there. And of course, so you can carry on as you are used to do it with CST Studio Suite. You can now maybe select the assign a port, or maybe define first the frequency, assign the port, and run your simulation. So, and as you know. So once the simulation is run, so in this case, so we can just speed up a bit the video. You can look at or watch the results either in CST Studio Suite, as were used, or you can, this data can be uploaded to the platform back, and you can use some web-based results visualization. So we offer a bunch of apps that allow to look at the result directly on web. You can see, let's say, watch the geometry, you can watch the 1D results, but even far field plot and electromagnetics fields. These apps are not only available as a web, but even on mobile devices, like your mobile phone or even tablet and so on. As you can see here, so we have a nice example where the basic patch antenna, where we can access 1D results, but even directly on your mobile phone, you can access far field results and so on. But let's move now to the first topic of, let's say, to the first bunch of workflows that we optimize. Let's focus on the antenna and microwave component design. Well, nowadays, when talking about antennas, we are really focusing a lot on the array. And I think CST Studio Suite is recognized to be offering today the best array task for designing array. And there have been many updates in 2023, starting with a ribbon itself that has a new layout. And we give the possibility to define subarrays as well. We have the possibility to define better the excitation in ribbon and so on, but even to have a kind of parameterization inside the parameterization list, the possibility to select the element that you want to simulate and even to assign or not an enclosure model. But I think the best is to see that in action. And we start with the Design Studio project that already has some enclosure and the two antenna block. So we create the array and import the layout. Then we switch to the group view and select the multiple model. So here we can group the elements and then select a specific antenna model that is assigned to each group. When moving to the element view, you can now specify the task in the parameter list if you just want to use one block for the moment. And you also have the option to load an enclosure on the radar. So then we move to the excitation. First, we select multiple excitation lists. And afterwards, we can decide which excitation list we want to use. So, and then we create the full array project by selecting, again, the elements that we want to simulate. So I think now in few clicks, so you get the frequency domain in this case, which is the most suitable for that. And the project itself has already defined the domain decomposition method. So as you see, so you don't need to, it's kind of simply go and let's say the domain are automatically created. So let's start with, let's start the solvers. And after the solver finish, you have all the individual port result as well, the full array partner constructing and post-processing. You can now switch to another excitation list by changing the index, and you can update the combined results template. And the pattern is updated, that it gets a new excitation weights. You will also notice that there are now two patterns. So if I switch to between the co and cross polarization, this is now actually a nice, let's say, capability that that you get again and again. So the everything is done as a post-processing, so you don't need to rerun the simulation. So we give then to the beam an angle, and a tilt angle by changing the scan parameter, and then we can go back to the let's say array task and take a look at the current excitation distribution as well as what you see here, the phase distribution. I would say extremely complete, very attractive for designer, and in addition, so we shouldn't always forget that we have the possibility to maybe take already some antenna, which are predefined. Our antenna MAGUS allows you to really start from a single antenna, but even to have some dedicated array pattern. And today's we added this year we added a new layout, which is a non-periodic, and it's a scalar array synthesis. So why this is helpful? Well, we usually, when you have periodic structures, you get a problem on the second lobe, which could be pretty high. So for example, this is kind of a classical Taylor configuration. If you use a sunflower one, so we can reduce already the grating, the second lobe, so we have a grating suppression, as well as this can be even improved if we have, as I said, so a sunflower configuration of the antenna. Antenna is not the only, let's say, it's maybe the most important devices for communication, but you need to have filters and so on. And our filter designer 3D, I think, is the best-in-class tools to not only create an initial geometry of the filter, but even to optimize that. And for the optimization, we use a space mapping, which allow us to really, for complex 3D geometry, like a diplexer or even like this coaxial cavity filter, to converge, to optimize response in 3D in 5 to 10 full wave 3D iteration. So these are different example that we have benchmarked, and you can see that you don't need to have 100 or even more than 100 of 3D simulation. It really, in few simulation, you get the convergence. Well, nowadays, the let's say most likely the most let's say standard, the most important standard is definitely the 5G, and to do that, to support this, we have developing a dedicated processing in the last 3 years. The 5G, the Wizard, has this year enhancement in the code book by having a better reporting and result type. For example, now you can calculate the equivalent isotropic radiated power, which goes directly then into the code book, as well as the new result template total scan pattern offer a switch of the antenna parameter in the definition dialog. In addition to that, we have improved the capability to report and to offer summary information. When talking about electromagnetism and of course radiation, I think we should not forget that sometimes we need to maybe evaluate SIR, or even we want to do deeper investigation of human exposure to electromagnetics radiation. And for that, I think we, even in this case, so we are the best in class to provide human model library. So this is updated every year. It offers a variety of different human bodies, but bear in mind, this is done in collaboration with the German Cancer Research Center, which in the Human Model Creation Project. These are very model detail coming from MRI scan, and these are available in the library extension. So you can just go to our access to Dassault website and download that. So these are mainly CAD, a voxel data can be used with our time domain based extraidal solver. But in addition to that, we provide even CAD data for SIR evaluation. This year we added the so-called landscape grip, so to kind of game mode that I think it's necessary for a proper SIR evaluation. So we have seen now how to in the communication system design. So we have focused until now on the antenna and filter design, but we haven't seen yet how a network can be planned as well. I will not talk about the public networks, the one where your mobile phone is connected and so on, but the emerging network, which is the private network. Dassault is extremely engaged in these topics. I would suggest you to visit our LinkedIn page, the SIMULIA LinkedIn page, where we have plenty of, let's say, demonstration on our capability. Today, Dassault Systèmes is the only company which is able to offer the digitalization of infrastructures as well as physical simulation on the 3D experience. Let's assume that you want to create a private network in your company. So first of all, maybe you have to scan, or you have already something that represent your company or your I would say hangar and so on. So that's the layout, which can be reconstructed. And then this can be imported, for example, in CST Studio Suite. And we can do different analysis. We can place one antenna, two antenna to check whether the coverage is good or not, or it's good enough. You can, of course, increase more and more the complexity of that. So you can see that maybe with the 3 antenna, it's fine. But what about if you introduce more details like a robot? So it's this robot able to communicate with that. So you need to have, in this case, we are talking about real-time network, since you want to really move the robot so in the real time. And this is available in this is possible already today with on the 3D Experience platform, on which CST Studio Suite provide the simulation for that. And that's why we are working on enhancing more and more the capability to represent a complete scenario, not only a simple model, a simple component like could be an antenna, but a complete scenario like this. So you can really have the possibility to represent this in 3D, but even to have a corresponding schematic. So why we need to do this double representation? Well, because you want to have a way to, from one master, to extract multiple scenario which can be derived. You can maybe want to have the jacks only, or maybe you want to have only the far field that you want to simulate, or you want to consider the hangar with the aircraft, and then you simply click on the schematic and you create your 3D structure for the simulation. Which solvers? Well, definitely for this kind of application, our asymptotic solvers is the best in class that we can, that the market, that technology can provide. Is extremely fast solver for even antenna placement, but even for radar cross-section, for example. And we can support GPU with the latest hardware acceleration. Important is, in this case, the definition of the analysis of the channel's impulse response, the CIR. For these reasons, we have been working in optimizing and improving the simulation workflows. You can find dedicated, let's say, script that allow you to evaluate that, as well as you can find dedicated post-processing, which helps you to evaluate the CRR as a, let's say, combined result. So very fast, very accurate at the same time. Well, If we stay in the area of the communication and detection system, so we have to consider two things. Well, antennas is definitely maybe the major actor for that, and we have analyzed that. But if you want to now evaluate your antenna in operating way, you need to evaluate for example, the antenna on an aircraft, or maybe on a modern vehicle like car or ship. And that's why it becomes important to decide or to have a bunch of solvers that allow you to choose the right one. But maybe at the end of the day, the best way, as I said before, to speed up the simulation is to choose the right solver. But sometimes it's not clear, or well, that there is not a best solution for that. And that's why, since many years, we have decided to hybridize them. So you don't need to choose one solver to solve everything, but you can choose, for example, model that require very fine and accurate meshing, and other that maybe consider the whole platform, which are maybe require simulation with another solver technologies. In such cases, our hybrid solvers come to rescue. It can easily combine multiple solver technologies to efficiently handle electrically large structures, and it offered both uni and bidirectional solution depending on the simulation needs. In version 2023, we have unified the hybrid solver task setup to get access to the speed of the unidirectional workflows, but keeping the robustness of the bidirectional workflows. The user can easily choose the coupling type from the hybrid solver task parameters list. The coupling is realized using the near fields. In addition to that, we have now the possibility to use the hybrid solvers in combination with the schematic. Sometimes when you have an antenna, you need to have some matching network together. And now we can therefore, which is done in with circuit simulation. So therefore, we can now hybridize matching networks with 3D inside the hybrid solver. I think that's most likely a unique tool offering that. Well, what else we have improved for the hybrid solver? So now the field source can be recorded at arbitrary frequency, not necessarily equidistantly spaced. This is, of course, saves simulation time and disk space for antenna-to-antenna coupling or for install antenna analysis over a large frequency range, since you have much better control which frequency you have to calculate. For example, you want to refine a particular band in comparison to other. As I said at the beginning, thanks to the 3D Experience platform, we are able to write dedicated app, which are industry, let's say, specialized. The antenna placement app, which is part of the 3D Experience role, is the first kind of app that we have developed. It's fully integrated on the platform, so it uses the same data format. It directly access the CAD model available on the platform itself. This year, we have expanded the app with some important features for example, like multiple antenna analysis and the coverage test. In addition, we added, we have the possibility to import let's say, the airframe, or maybe a vehicle, could be a car, directly as a mesh. So you don't need to remesh that at all. I just show you a few seconds a video how this works. So, well, the antenna placement is available on the platform, on the 3D Experience, so you can import your aircraft in this case. It's done as a mesh. The antenna is a CST project that you have uploaded to the platform before. And well, you can use different possibility then to place the antenna and to in different positions. So, and then you can create the different, let's say, placement candidate, which can be, I would say, swept afterwards. So you can either position it interactively, as you have seen before, or maybe by defining the, let's say, the the position by coordinates. Here we go. Well, what else we have improved? So we have now the possibility. Well, we already could do it before. We could define the obscuration plot. So this is the antenna radiating, and what we see here is where the antenna is radiating well, and where the platform, in this case the airframe, is doing kind of shadowing of the antenna itself. But we have the possibility to define a smaller angular range to be more precise in some area. So that's related to the antenna placement and antenna to antenna coupling. But yeah, this is not enough sometimes to define if your system is working or not, because we have to consider the full RF channel. And to do that, we have our interference task, which provide you the possibility to combine the antenna to antenna coupling, but even to add the different RF module to that. For the 2023, we have intensively worked on the end-to-one task for the interference task. What does mean the end-to-one task? So, well, you start with, for example, two antenna transmitting, which are interfering with one receiver, or moving to the second receiver, or you can choose another two antennas which are then interfering both of receiver one. But we can even choose three antennas that are all possible combination with this transmitter. And well, this is now all this combination can be done automatically. And for each case, the interference check, for, as I said, for all possible channels combination, considering only one channel per transmitter. So as at the end of the day, so you can end up to a large number of, let's say, simulation, but what we did it, we have further improved the efficiency of the single simulation. So it is now used much less memories than previously, as we can see in this example. So we really drastically reduced the amount of RAM necessary, but even the total simulation time up to factor of 10 in many cases. So therefore, we are able to provide at the end of the day, so full range of tools for antenna design. When putting the antenna in the array, then we can do the private network planning. We can do antenna placement for a full communication system design by having then the interference task to really have you know, a complete analysis for that. Now let's move to another, I would say, fascinating chapter of what we can provide, the electromagnetic compatibility. Well, we are recognized as technology leaders in the electromagnetics. So we, I think since at least a decade, we are able to solve problems that our competitors are still struggling to do. And therefore, let's say the focus is not only on enhancing the technologies, but even enhancing the workflows to smooth how to set up an electromagnetic compatibility issue, which usually tends to replicate a measurement setup. And that's why we have a kind of, we provide release this year, a wizard. So you can go on either on the 3D or even on the schematic part, and you have a button So internally it's called the EMC button, which allow you to have a step-by-step kind of tutors that tells you what you have to do it. So you start from, for example, from a template. You can access even a library where you have not only 3D model, but you have even some scenario setup, for example, with the lens available. In addition to that, we can provide a signal library and even some EMI receiver setup. Let's try to see this a bit more in details. So you start with EMC standard limit. You can with some predefined EMC common standard, and this give you on the results the mask that you can use afterwards to verify your compliance. Of course, you can use even an interface to mimic the EMI receiver for easy post-processing, and you can compare easily the results with different technologies. When talking about EMC, of course, we are talking about electronics and PCB. We are, I think, really the number one in offering ECAD MCAD collaboration. And this year we have enhanced the schematic part as well. So when you import from ECAD, could be Cadence, could be Mentor, could be Zuken or Altium, whatever, or DB++, we are now able to have on the schematic to automatize the setting of the circuit. On the left side, you see a typical EMC scenario, which needs to be done manually, not anymore. So starting with a FD01, so you can have you have your classical, CST block on the CST schematic. The lumped element, for now it's limited to the lumped element RLC, are automatically placed even parametrically. So you can really then do a parameter sweep. We work a lot on sampling. Well, when moving in the electromagnetic compatibility, we usually use a digital signals for excitation, and therefore we have to switch often from time domain to frequency domain. Therefore, the sampling is important, and we have unified the sampling. If you have a 3D model, if you have a circuit, but even if you have the combined results. So that's why when you start with a 3D model, we usually apply a logarithmic sampling at low frequency. We even try to add some, for example, frequency evaluation frequency at 1.0 to be very accurate at low frequency. Now, when moving to the circuit, we do not resample that anymore. This is important. So we keep the same accuracy when doing the vector fittings in Design Studio. And we offer as well new vector fitting settings for the blocks itself in Design Studio. Now, when you do the time gating, or you apply a different windows to do the time to frequency domain transformation, so to calculate the Fourier transformation. So we are automatically estimated the number of sampling that you need to have a proper, let's say, evaluation of the peak. Why that? Well, because at the end of the day, you see how somehow narrow are these peak. And if you do not have an intelligent way of sampling, you may miss this peak, or you can create aliasing. And this is a classical, let's say, problem that both, let's say, simulation tools, but even measurement system can create. And that's why, so we have worked a lot this year to make this stable and stable. Regarding the frequency domain solver, so I just want to mention two features that I think are available since last year. They have been made more stable. One is the thin panel, which allow transparency of the at low frequency for the electromagnetics material, and the possibility to import tetrahedral mesh directly in the frequency domain solver without the need to remesh that. So in this case, if you remember, so this car is from 2 minutes versus 1 hour that we have done before. We have still some limitation, but we are going to remove that in the next service pack. When talking about EMC, never forget that cable is usually not a source of interference, but they transport the interference from one point to another of the system. And what we did, it's a long time or well, multi-years project that unified the way that cables excitation are defined. So it's actually now the same. So we have a port for cable, while in principle before we are just defining pins. And for you, you can now run cable simulation with true transient simulation directly in 3D without accessing the schematic setup. So you can really do this kind of, let's say, 3D plus cable simulation in a very efficient way. We reduced the number of pin afterwards on the schematic part, but you can really streamline your workflows by using distributed computing. You can use combined results, and you can use MPI to speed up your simulation with Cable Studio. So we really streamlined the workflows. There is no different anymore how Cable Studio and I would say so the Micro Studio parts are now working together. But if you really want to go to an extremely high level, high accuracy, or even you want to use Cable Studio to then set up a thermal analysis, we have a functionality to create 3D cable from the Cable Studio information that you had before. Let's move to the almost last topics for today, which is the low frequency and the electromechanical device design. Well, as you know, our flagship product for the low frequency application is Opera. Opera has joined Dassault in 2018, and we have working every year to integrate more and more Opera inside CST Studio Suite and on the platform. In 2023, we are able now to install Opera through CST Studio Suite, so you don't need to have two different installation. This has a lot of advantage. So you have a unique license server. You have a unique installation location, but maybe that's the most important. Now you have an update manager that every service pack is able to update CST Studio Suite and Opera. So that's a very good way to, how can I say, leverage the best of our tools. But we went a step further. Opera is the recognized best-in-class tool for low frequency, especially for magnet simulation. And now we can find Opera solvers inside the CST Studio Suite. So that's the CST Studio Suite GUI. Even the electromagnetics engineer can offer that. We leverage the best-in-class technologies for magnet simulation. You can see this is the mesh still in CST Studio Suite. And if you go to the list of solvers, you will find Opera, the M-static for starting. So we start, and after at the end of the simulation, the results will be available into CST Studio Suite interface. That's, I would say, fantastic. So we are going to offer more and more solvers in the near futures, but I would say the big step to really unify in one single GUI the best solution that, let's say, SIMULIA can offer for electromagnetics. But we continue to develop our capability, for example, for induction machine. We added to enable the simulation few new features. The main problem for induction machine is the fact that due to the initial transient, there is a slip between the stator and the rotor field, and that becomes simulating the induction. It's get a challenge. So first, the time constant is not known a priori and depend on the operating point, and second, the simulation in 2D needs a field circuit coupling, as can be seen when looking at the typical squirrel cage rotor. What we did, we actually solved both challenge by, or at least we addressed both challenge in 2023 by developed a field circuit and an automatic steady state detection. So as you can see here, so you can couple the let's say the cage with a schematic, so we can see a circuit with a 3D bar squirrel cage rotor. The vertical path are the simulated in 2D FEM, including the right source for that, and your horizontal segment represent the end rings, and these live and on the circuit side. And of course, as I said before, we have to identify when the steady state is reached to stop that. This is an additional solver features. It takes a wished accuracy level, the fundamental period, and a loss monitor as an input. So to properly set the period, we provide a VBA command in this case, but we are going to announce with a dedicated GUI to have a clear, let's say, as a function of the sleep and stator's supply frequency. This is how the results look like. To the top left, we see, for example, the currents of the two bar in green and blue together with impressed phase current on one phase, which is in red. One can clearly see the different periods, and on the right side, we see the steady state detection results, and which is done after one fundamental period. And the simulation stop when the smooth change of the mean reached the dedicated accuracy, which can be seen here. Well, let's finish with how you can maybe speed up your simulation time in, I would say, easy way or scalable way according your needs. To do that, we have introduced GPU cards like the RTX A series. These cards are so less performance than the Tesla one, but they are cost-effective solution. So for many simulations, so you you don't need so higher accuracy. That's why you can maybe start with this solution if you want to have your own, let's say, internal solution. But these are the typical speed up factor that you can get with a Tesla that usually you cannot get with the RTX. Bear in mind that the simple model provide less speed up. The more complex the model, more speed up you will get. In this case, we have up to 10 times speed up in the solver loop. And this is provided, for example, for the time domain or for the asymptotic solvers compared, for example, to the dual X Xeon Gold. But if you want to have a scalable computing capability, I would suggest you to move to the 3D Experience Cloud. The 3D Experience Cloud allow you to upload the or to have a cloud computing. So you don't need to have your own computing system, but that's available and provided by Dassault. To do that, you need to have a CST Studios license, of course, active. You need to buy the All Physics Analyst role, which allow you to connect CST Studio Suite to the platform, and then you need to buy a certain number of token or credits according the let's say the hardware that you want to choose. We have several hardware configuration that try to cover the main application that we have. But this year, and this is done through the simulation manager, where this year, so we support all CST Studio Suite 3D solver. We support the schematic based solver, for example, the hybrid one, not yet the distributed computing, but it's coming soon. And if we, the big news is that not, let's say you can easily set up the, say the simulation scenario. So you can then go to the platform and you can, at the end, either sorry, I go one step back. So you can go to the platform, you can launch the platform, you can see the 1D results on the platform itself. Or you can even lightweight visualization of these results, or you can download the results, and afterwards you can look it in your desktop version. But this year we have introduced for the electromagnetics engineer the possibility to access the platform from to access CST Studio Suite GUI user interface directly from the cloud. So what you are seeing now is, I would say, a widget. This is embedded in your web browser. So it's not installed on my machine. So you see, you open that, and what you see, it's really CST Studio Suite GUI. So you, in this case, we had already set up the simulation. You can look at 1D result, 3D results, and it's really very fast, time responsive. You can do it, let's say, using the electromagnetics engineer. I would say that's a big enhancement. So we provided the post processes as well, and that's a great way to, I would say, to have your experience fully on a cloud. So before opening the Q&A session, I would like to summarize today some key takeaways. Well, thanks to the experience platform, the electromagnetics engineer, which can connect people, data, and process, you can even today use the cloud to remove the barrier for accessing high performance computing, but even to allow user to have a unique experience on cloud only. Our array task has received as many enhancements that allow advanced MIMO and even subarray workflows. For antenna placement, we have enhanced our hybrid solver, especially for the unidirectional coupling, which supports schematic that takes into account matching networks. We have updated a lot in terms of performance as well, the interference task. For the electromagnetic compatibility, we introduced the wizard, which is the starting point for the simulation workflows. And we continue integrating Opera solution into CST Studio Suite and on the platform as well, on the electromagnetics engineer, by having the first version of Opera magnetostatic solver with CST Studio Suite GUI. Well, thank you very much for your attention, and we still have a few minutes to answer some questions. Please enter in the community.